So we're in section 1.1. And this one is titled Evaluate Expressions. So I'm going to give you a couple definitions here. So a variable is a letter used to represent one or more numbers. So typically we use like X or M or N, Y, Z sometimes. Other letters can be used, but those are the most common ones that get used. Then we have an algebraic expression. And this is an expression that includes at least one variable. And then just a couple of little like notation things here. If we were going to do multiplication, okay, with like an algebraic expression, this could be written a couple different ways, so I'm just going to kind of show you some of the ways that the book might write it, and so that way you know what it means in each of those cases. So if they do 5 and then a parentheses and an N inside the parentheses, that would be one way that they might write multiplication. Another way they might do it is 5 and then the little multiplication dot and then N. And then sometimes, because you have just a number and a letter beside each other, the other way that they'll write it is just write 5N, which is going to be the most common way you'll see me write it when I'm doing stuff. Just because it's the shortest, easiest way to write it. Now, you may have been used to previously seeing it written like this, like 5 times N, but in algebra that gets confusing because X can also be a variable. And so it can be hard to tell the difference between a multiplication symbol and an X like as a variable, and so we don't use this one anymore. Okay. Not to say that on occasion a worksheet might not write something like that, but your book and the way I'm going to do things is always going to be like this. Either with typically I'm going to use this one first, and then I would use this one. So I almost actually do them in reverse order of how I wrote them up here. If it's a number times a number, then I'm probably going to write it with parentheses, but if it's a number and a variable, I'm almost always going to write it like this one. So then if we had instead division, it could be written one of two ways. It could be written as something like 14 over y, so it could be written as a fraction. Or it could be written as 14 with the division symbol and then a y. Okay, and that would mean the same thing. There. And then obviously with addition, they're not going to do anything crazy. Addition and subtraction are just like normal. something like 6 plus c, and then subtraction, still the same thing, 4 minus x, something like that. So really the only ones that might be a little bit different from what you're used to seeing is multiplication and division, addition and subtraction. Nothing changes. All right, so then the next thing, so some more definitions, is a power. And this is an expression that represents repeated multiplication of the same factor. So I'm going to give you a couple definitions, and then I'm actually going to show you what this looks like. An exponent is, or you could say it represents the number of times the base is used as a factor. And then the base is just a number that's being raised to a power. All right, so we have an example of this. So leave a little bit of like a line above this, so skip like one line to write this, and then that way I can write some stuff above it. So we have, if you have something like 3 and then a little 4 that's up in the top right of it is equal to 3 times 3 times 3 times 3. Okay. So this 3 here, okay, on the left-hand side is the base. Okay, so that's the number that's getting repeated. Okay, this 4 here is your exponent, and it tells you how many times it's getting repeated. So I have 4 3s. Okay. This whole thing, so both of those pieces together are the power, okay? And then all this part means over here is that there are 4 factors of 3, or that we have 4 3s. Okay, so the number in the top tells you how many times to write it, and then the bottom number, the big number that's the base, is the number that you are writing that many times. So if you had something like 2 raised to the 8, okay, and that's how we'll say it is 2 raised to the 8, or like the 8th power, because that's another way you can say it. This means that we have how many 2's? Okay, so we have 8 2's, so it would be 2 times 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 2. I think that's 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that's how many you would have. So if we were actually multiplying that out, we would have 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which is 64, and so on and so forth. You get the idea. Okay, but that's all that means. And sometimes, rather than it being a number that is your base, you may have a variable that's your base. So you could have something like n to the 4th. Okay, so that means n to the 4th power, meaning I have 4 n's. So you would have n times n times n times n if you had something like that. All right, so it kind of works out that we just did that one little perimeter problem because this section has a little bit with area and volume. So I'm just going to show you kind of what that is and how that's going to come into play here. Except for this time, we're going to do it for a cube instead when we do volume, or a square when we do area. Okay, so if we had let's do this, area of a square. Okay, so we would have a square. Then each side is the same length, right? That's what gives us a square. If we have a different side, 2 different side lengths, and that becomes a rectangle. Now, fun fact, a square is also a rectangle, but a rectangle is not a square. So, if we had area, okay, what we do is we multiply one of the sides times the other side, and that's going to give us area, okay? So, area is equal to side times side, okay? Or, now that we have this, okay, if we had, I'm going to do the n's because there's lots of them, n times n times n times n, okay, then I could rewrite that as n to the 4th. So I have 2 s's, so how could I rewrite that?
S to 2.
Yep, so s to the 2nd power. So that would be my formula for area of a square. And then if I had the volume of a cube, it's going to be similar. I'm going to do my best to draw a little cube here. We're going to see what happens. Also, just fun fact, if you ever like, oh, she's drawing really perfect like squares and circles and stuff, my iPad will actually do it for me. Like, it'll change stuff for me. So I'm not that good at drawing, I promise. So if you ever see that, like, I can draw circles. I can make them look really, really bad, and then the iPad makes them look really, really good. So I'm not, I'm not that good at drawing squares. Usually I like blow people's mind. They're like, whoa, you drew that? I sure did. All right, so volume is very similar. Okay, when it's a cube is just 6 squares put together. Okay, look at that. I actually have cubes sitting right here. So a cube, it's just 6 squares that are put together. Okay, so the only difference between volume and area is that, where did I put it? Okay, every side is the same length, okay? So I have the height of it here. I have a width and I have a length, okay? And they're all the same. Okay, so I could label all of them if I wanted to, but for not confusing you, I'm just gonna write the 3 that we need right here. Okay, so volume of a cube is equal to side times side times side. So how could I rewrite this one like we rewrote the area one?
S to the third.
Yep, so S to the third. And so a volume of a cube is S to the third. So whatever the side length you're given, you just multiply it by itself 3 times. Or well, yeah, there's 3 of them. All right, so let's start looking at some examples of stuff here. So we have the first one, say to evaluate the expression. So number 4, we have 0.4 r when r is equal to 6. So what they want us to do with these ones is to put the number that they give you as the variable here in for it in the equation. So you would have 0.4, and then because I'm going to be putting in a number in its place, okay, I'm going to use parentheses so that I can see that I'm doing multiplication. So I have 0.4 times 6, okay? So then if I did 6 times 0.4, what would you get? 24, and then because this decimal place is 1 over, I'm going to take this and move it over, so it's going to be 2.4. So however many decimal places you have when you're multiplying like that, you have to move it over that many spots. All right, number 6. We have 1.6 minus g when g is equal to 1.2. So I'm going to put this 1.2 in for g in the equation. So I'm going to have 1.6 minus 1.2. So I think it's easier with decimals to line them up like this. So 1.6 minus 1.2. So 6 minus 2 would be 4. And when you're adding and subtracting, you just bring the decimal point down. Okay, it's only with multiplying that you're going to end up moving it over. And then 1 minus 1 is just 0. So this answer is just 0.4. All right, 8 is 0.8 plus h when h is equal to 3.7. So we're going to put 3.7 in for h, so I'm going to have 0.8, okay, and you don't have to write the 0 before, so I usually don't. Plus 3.7 So if I were to do that, I'd have 3.7 plus 0.8. Okay, so 8 plus 7 is 15. So I have the 5 here and I carry the 1. Since I'm adding, I just bring down the decimal point. And then 3 plus 1 is 4, so the answer would be 4.5. Let's see, another one. Number 10. We have t over 5. Okay, so that means divided by when t equals 4.5. All right, so we're going to put 4.5 in for t. So 4.5 over 5. And now I'm going to have to do, well, I'm going to say long division, but it's really going to end up being short division. So we put the 5 on the outside and the 4.5 on the inside. Okay, so with this, when we have a decimal inside, we always put it directly above where it goes. 5 can't go into 4, but how many times can 5 go into 45? 9. So then 9 times 5 is 45. Subtract. That's going to give you 0. So the answer is going to be 0.9 for that. Alright, let's do another one. Number 12. 1/2 k when k equals 2/3. So we're going to replace k with 2/3. So I have 1/2 times 2 over 3. Okay, and again, because I have a number times a number, I'm using the parentheses around the one that I'm plugging in. So what can I do here? Y'all tell me. Since I'm multiplying two fractions, what am I able to do with that? No, if I was dividing, I would flip it. What do I have on the top of one and the bottom of another? So I'm going to cancel the two that are opposite each other. So I have a 2 on the bottom and a 2 on the top, so I can get rid of those. And then I'm left with just a 1 on the top. And then because this 2 became a 1 on the bottom, I'm just left with a 3 on the bottom. So the answer is just 1/3. All right, and then the last one for today is number 14. We have h plus 1/3 when h is equal to 1 1/3. So I need to be able to plug in that value of 1 1/3 for h, okay, but I can't really do anything with the mixed number, so I need to change it. So how would I rewrite this mixed number as a fraction?
Multiply 3 and 1, and then add the 1.
Okay, so what would that give me?
4 over 3.
Okay, So that's 4 over 3. So I'm going to plug that in now. So I have 4 over 3 plus 1 over 3. And what would that give me?
5 over 3.
Yep. So the bottom stays the same. We just add the top. So 5 over 3, and then the book is going to always rewrite them as a mixed number. I would be okay if you left it like this, but what would that be as a mixed number?
1 and 1. No, 2 over 5.
2 over 3.
Oh, so easy.
So it'll be 1 and then 2 over 3. Any questions about any of those ones? All right, cool. We only have a couple minutes left, so we'll just pick this back up tomorrow.